Welcome. This video is going to talk about mixtures, which are different than the pure substances we've been talking about so far this year. Remember, pure substances are elements or compounds. Mixtures are another form of matter, and in fact, most forms of matter occur as mixtures. It's a combination of two or more substances that come in contact with each other, but each substance keeps its basic identity. So in other words, no chemical reaction is going on, no bonds are forming. So physical properties like density and boiling point will change, but not the chemical properties. So for example, when you put salt in water, it tastes like salty water because the salt and the water are each retaining their properties. And even though it'll change the boiling point of pure water, it won't change the chemical reactivity of the pure water. So there's two kinds of mixtures. You can have a mixture that is equally mixed throughout or the same throughout called homogeneous or homogeneous, and those are also referred to as solutions. Or you can have a mixture that is not evenly mixed, and that would be heterogeneous, and it'll either be something called a colloid or a suspension. So this chart here kind of summarizes the two big categories of matter. Matter is either considered a substance where it has a definite composition and we can write a chemical formula for it, or it's a mixture that has a variable composition so we don't have a chemical formula for it. For example, salt has a formula, NaCl, and water has a formula, H2O, because they're each substances. But salt water has no formula. We find other ways to represent mixtures using things like concentration and molarity. And then again, mixtures can either be homogeneous, uniform throughout, the same composition, a solution, or it might be non-uniform throughout, and then it's either going to be a colloid or a suspension. So how do we decide which of the three mixtures we're dealing with? Well, you can tell some by just looking at it. Physically, you can get a pretty good idea. But to be sure, you have to use a laser and something called the Tyndall Effect. The Tyndall Effect is when light gets scattered by particles in a mixture. So this means bigger particles in a mixture will scatter light, and small particles won't scatter the light. So this helps you identify if your mixture is a solution, a colloid, or a suspension. And what you're really doing is you're finding out if it has really small, medium, or fairly large particles in the solution. So again, the scattering of the light is caused by particles suspended in a colloid or suspension because of their larger size. Solutions have the smallest particles, so they're not going to exhibit the Tyndall effect because their dissolved particles are too small to scatter light and they're too small to settle out like a suspension would. So some examples of where you see the Tyndall effect in your day-to-day life is when they do a laser light show, they deliberately get a lot of vapor in the air to help create that Tyndall effect, to help scatter the light so we see it. You see the same thing when you're driving in fog. Your headlights tend to bounce off the water vapor in the air and create some issues for you visibility-wise. You also see it when you can see the sun's rays shining through a cloud or filtering down through the trees or maybe even through the blinds on your window. That is also the Tyndall effect. Here's an example of it. If you look at the laser, the mixture on the right is a solution because I can't see the beam passing through. I can see the red mark along the side here. I can just see it as it hits the glass, but I don't see the beam passing through. Over here, however, I see the beam passing through, so it either needs to be a colloid or a suspension if the Tyndall effect is observed. In this case, it's a colloid because there's no bigger particles settling out. So solutions must be homogeneous or homogeneous, meaning it's the same throughout. They'll appear clear. Now, clear is not the same as colorless. They may have a color like orange soda, but they're clear. They will not have any settling, so they can't be filtered with like a coffee filter. They do not exhibit the Tyndall effect. And again, the reason they don't settle, can't be filtered, and don't exhibit the Tyndall effect is because solutions contain the very smallest solute particles. The atomic size is going to be less than a nanometer. Not that you have to know that, but you should realize solutions have the smallest particles. So examples are salt water, Kool-Aid, or soda. Colloids are heterogeneous, not the same throughout. So if you looked at it under a microscope, you would see some variations. You wouldn't see the same pattern throughout. They tend to have a cloudy appearance, although it can be difficult to tell. Sometimes a solution will look, or a mixture will look quite clear, and yet it will exhibit the Tyndall effect. Like the previous picture, those two solutions look pretty close to the same, I should say two mixtures, and yet one was a solution and the other was a colloid. Colloids also have no settling and can't be filtered, but they do exhibit the Tyndall effect, and that's because their particles are bigger than an atom, between 1 to 1,000 nanometers, so they're big enough to scatter light, but they're not so big that they can be filtered out or that they'll settle out. So some examples are milk, mayonnaise, motor oil, blood. Any kind of cloudy liquid you can think of is most likely a colloid. A suspension then is the other heterogeneous mixture. They're also going to be cloudy, and they're going to settle over time and separate into 2 or more layers. So they can be filtered, and they do exhibit the Tyndall effect. And they contain very large particles compared to the other dissolved solutes in a colloid or solution. These are dissolved particles larger than 1,000 nanometers. So this is things like muddy water, orange juice, aerosols. Anything that you have to shake before using is a suspension. So to finish up, I want you to think about the steps you would use to decide if a mixture was a solution, a colloid, or a suspension. And basically what I would do is I would look at it first, and I would look to see, does it appear clear, cloudy, or chunky? If it appears clear, it's most likely a solution. So to be sure, I would check with a laser. Check for the Tyndall effect. And if there's no Tyndall effect, if it's clear with no Tyndall effect, then I know it's a solution. If it appears clear but it does exhibit the Tyndall effect, then I know it's a colloid. Maybe just a very weak colloid without a lot of the solute dissolved in it. If it appears cloudy, then I can assume it's going to have the Tyndall effect. And so then the question is, can I filter it? Does it filter or does it settle over time? If the answer is no, this is also a colloid. But if it can be filtered or does settle out, then I know I have a suspension. And if it appears chunky, then I just want to look to see if it can be filtered or if it settles. Chunky usually implies it settles. And again, yes, lets me know I have a suspension. Not quite fitting that. If for some reason I couldn't filter it, then this would just be a chunky looking colloid, but unlikely.